Good evening. I will be hosting the Physics Masterclass, appropriately named Physics 0.5, to represent the high school level physics that we're doing. Today, my lesson will be on 2D kinematics, specifically symmetrical projectile launch. Some prerequisites before this lesson is understanding trigonomic functions such as sine, cosine, and tangent. The ability to substitute values into variables, and lastly, you need a calculator because of the trigonomic functions, and also like dividing a lot of things. So let's start with a problem. Let's say you have a ball and it is kicked at 50 degrees at 12 meters per second. Now, what this is telling us is that at 50 degrees, we can basically make this into a triangle. At 50 degrees, the hypotenuse is 12 meters per second. And basically, we want to reverse engineer to find these two legs for the initial velocity. So what you always want to do when presenting with this is find the initial velocity, horizontal and vertical and horizontal component, which will be appropriately labeled x and y. Don't mind me, I'm just going to write down all of the variables we will need to know. Okay, so the first way we can find our first step should always be labeling our acceleration. For our y value, our acceleration will always be negative 9.8 meters per second squared unless told otherwise. If not told otherwise, it will always be default negative 9.8 meters per second squared. This is the acceleration due to gravity on Earth. For our x, in 2D kinematics, it will always be 0 meters per second squared. Alright, so let's get to finding the initial velocity component x and y. So let's start with y because it will tie in a little later. So we can do this by doing sine 50 degrees times the 12 meters per second we were given. And that will equal to, oh god, hold on. This is why we need the calculator. This is sine 50, 12 meters per second. We get 9.1 meters per second for our initial velocity y component. So with this, alright, sorry, I messed up my train of thought. Our next step with our y is that we always want to find the apex, which I like to call the half point, because since this is symmetrical, this side will always mirror this side. So by finding the half point, so it is by far the easiest to find the half point, because by finding the half point, we can find time. And a little background on physics, every apex of a symmetrical launch the velocity will always equal to 0. It is not going up nor down. A period instant in time, it is not moving at all. So that's how we find the apex. So we can substitute that apex with 0 meters per well, I'll be using this first equation. 0 meters per second to represent the pause in velocity at the apex. The initial velocity, which we found out was 9.1 meters per second, plus our acceleration, which is negative 9.8 meters per second squared, and our time, which is, we don't know time. We're trying to find this variable. So what do we do first? Well, we want to isolate time, and our first step would be subtracting this 9.1 meters per second on both sides. And there will be negative 9.1 meters per second is equal to negative 9.8 meters per second squared t. Now, since this negative 9.8 meters per second is the coefficient to t, we actually have to divide negative 9.8 meters per second squared. And what we're left with is, this is why we also should have a calculator. 9.1 divided by 9.8 will equal to 0.92 seconds. Actually, this rounds up to 0.93, but I don't really care. You get 0.92 for, let me remind you again, your halftime. What we are looking for is your full time. So your half times 2 equals your full. So all we need to do with this 0.92 halftime is multiply it by 2. And we'll get 1.84. Simple as that. 1.84 seconds. And before I move on to the next step, which would be the x, notice how I didn't put the y or x on time. That is because time is the only constant that can travel in between the two x and y. If it makes sense, like time is independent from these other variables. In fact, these other variables are dependent on the time. So that would mean that the full time for the x would also be 1.84 seconds. Alright, so we already have our vertical component. We can find everything else out by doing simple equations. Or by logic, we know that since this is symmetrical, the final velocity would be negative 9.1 meters per second as it's going down. As this instance, it was going up. And our displacement would be 0 because we're looking for it going up and then it going back down. So, hold on. Our next step is to find the y component the x component of the, sorry, I'm getting a little distracted. The x component of this whole system. We want to do cosine 50 degrees times the 12 meters per second. With that, we will get the value of cosine 50 times 12. And that'll equal to 7.7 meters per second. So with this, we can input 7.7 meters per second in both the initial and final velocity, believe it or not. Because our acceleration will be 0, so there will be no variation within the velocity. So our only thing left to find is displacement, and we can use this function. So it'll be our displacement is equal to our initial velocity, which will be 7.7 meters per second, times time, which will be 1.84 meters per second. Not meters per second, just seconds. What am I doing? Apologies. Plus 1/2 our acceleration and time squared. And our acceleration and time squared will all be canceled out because our acceleration is 0. So this whole portion that is being multiplied, gone. We don't want to see it anymore because there's a 0 there. So all we're left with is 7.7 times 1.8. Oh. Uh-oh. Sorry. I have to fix the mic. All that's left is 7.7 times 1.84. And you're left with D equals to 14.168 meters, because these seconds cancel out and you're left with meters. Yeah. Imagine getting all of this information just from the angle of launch and the velocity of launch. This concludes my first lesson on Physics 0.5 Masterclass. If there are any more prevailing questions on any process or steps, or if you just want more examples of 2D kinematics with symmetrical launch, just shoot me a message. I'm pretty sure all of you guys have my Instagram. This should conclude this first lesson. So yeah, thank you everyone. Bye-bye.